Welcome. So in this video, we'll be answering this question before us. It says, let f of x be equal to this. The function f has a maximal domain. For part A, what we need to do is find f of 0. And this is worth 1 mark, and we're going to be using our trusty cas to answer it. So we come to our cas, and we come here, and we're going to begin by defining what our function is. So let's type in f of x, and then let's go control this, and then type in what we see here. So it's 1 over x minus 2 squared minus 1. And just double check that you've written it down correctly. That looks good. Now we're going to sub 0 into this. So we're going to go f of 0. And we're going to get negative 3 on 4 out. So let's now write that in. Because it's only worth 1 mark, no working is required. So I'm just going to go f of 0 is equal to negative 3 on 4. The next thing that we have to do here for part B is solve f of x is equal to 0. It's worth 1 mark. So yet again, we will use our cas calculator. We're going to go menu, we're going to go algebra, we're going to go solve f of x is equal to 0, comma x. And as you can see, we get 2 answers out, 1 and 3. So let's now come over here and write down what we found. X is going to be equal to 1, or x is going to be equal to 3. So again, because it's only 1 mark, no working is required. Let's now come here and again, pull out your highlighter. On the set of axes below, sketch the graph of y equals f of x. Indicate clearly any axis intercepts and asymptotes. So very important that we label our axis intercepts and asymptotes. Let's just begin by reminding ourselves what f of x is. It's 1 over x minus 2 squared minus 1. We need to be able to identify immediately that this is a truncus. And because it's a truncus, we know what the general shape of it's going to be, and we know it's going to have 2 asymptotes. One of the asymptotes, because I have x minus 2, is going to be at x is equal to 2. It's being moved 2 to the right. So let's put that in. And the other one will be y equals negative 1. So right here. Once we've done that, we're now going to get our pen and we're going to draw in what we have. So it's going to look like this. So because it's a truncus, we know the general shape of it. It's going to be like that. It's going to be like that. Let's put some arrows. And remember, it should be approaching the asymptote, but never touching it. If your line crossed the asymptote, you will lose marks for a bad graph. It should not be touching it, nor should it be like veering away from it as well. You want it to look like it's touching it. Now, I've just realized that I have not drawn this correctly, because as you can see here, it looks like it's passing through the origin. But we know what the intercepts are going to be, because we found them up here. So here, when we let x equal 0, we found this. So this is our y-intercept. So this is our y-int. And over here, when we let y equal 0, we found our x-int. So that tells me that my x-intercepts are 1 and 3. So I'm going to have to try to draw this thing again. So it's going to look like this. That's a bit better. So this right here is going to be 1 and 0. This one over here is going to be 3 and 0. And this here is going to be 0, negative 3 on 4. So we're utilizing what we found in part A and B because they lead on to graphing this successfully. So just to repeat that, here we let x equal 0, which gave us our y, and here we let y equal 0, which gave us our x's. So 1, 3, negative 3 on 4. Make sure you're writing them as coordinates, and make sure you also have your asymptotes labeled as well. So if you don't have your asymptotes labeled, and if you don't have your points, your actual intercepts written as coordinates, you will lose marks. Okay, let's keep on going now. It says write down the domain of f. So remember, the domain is all my possible x values, and as you can see, x exists everywhere except for 2. So I would say that it's all real numbers excluding 2. For the range, remember range is all the possible y values. Y doesn't exist below y equals negative 1, but then it exists everywhere above it. So I would say negative 1 to infinity. But you don't include negative 1 because negative 1 is the asymptote, so nothing exists there. But everything above that, there are y values, but nothing here. Okay, perfect. Next, the graph of the function y equals 1 over x squared has undergone 2 transformations to become the graph of y equals f of x. Describe completely each of these transformations. So let's just remind ourselves what f of x is. It's 1 over x minus 2 squared minus 1. So this minus 2 here is telling me that I have a translation of 2 units in the positive x direction. And then this minus 1 is telling me that I have another translation of 1 unit in the negative y direction. I wish it didn't take me so long to write. 1 unit in the negative y direction. Or, to put it simply, this 2 is telling me that I'm moving 2 units right, and this negative 1 is telling me that I'm moving 1 unit down. But make sure you use the word translation of 2 units in the positive x direction, translation of 1 unit in the negative y direction. We're being very formal to get those full 2 marks there. Last one. The graph of y equals f of x, let's get our highlighter out because I see some important things here, is, oopsie daisy. The graph of y equal f of x is translated 2 units to the left and then dilated by a factor of 2 from the y-axis. Okay, so let's just figure out what exactly this is going to look like after those have taken place. So I'm starting off with, let me zoom out actually so I can see what's here. I'm starting off with y is equal to 1 over x minus 2 squared minus 1. Now I'm going translation of 2 units to the left. So that's undoing this minus 2 here because this is to the right. So I'm going to end up with 1 over x squared minus 1. So I have dealt with this one. Now I have to deal with this one, a dilation by a factor of 2 from the y-axis. So remember, when you're dilating from the y-axis, you take the reciprocal of this right here and you sub it into the x spot. So that means what I'm going to end up with here is y equals 1 over. Now into this x spot, I'm going to put x over 2. So I'm taking the reciprocal of 2, which is a half, and it's going to look like that now. Or to put it another way, I'm going 1/2 x. That's the same as x over 2. I'm squaring it, minusing 1. So I'm going to end up with 1 over 4x squared. Now you can write it like that, but I just prefer to write it like this, x squared over 4 minus 1, and then you should know that I can now just rewrite this as 4 over x squared minus 1. That right there is what I will be graphing now. So let's highlight it. So after these transformations have taken place, that is what I'm dealing with. Y equals 4 over x squared minus 1. Okay, so let's now give this a graph. So it says on the set of axes below, sketch the graph of the resulting graph. Clearly indicate on your graph any axis-intercepts and asymptotes. So let's immediately just put in where our asymptotes are going to be. I'm going to have one here at x equals 0. And I'm going to have another one at -1. Then what I'm going to do is I'm going to give this thing a sketch. So it's going to look like this. Like this. I then need to figure out what these points are going to be. To do this, there are a couple ways you could do it. I think I would just give it a bit of a sketch here. So 4 over x squared minus 1, it's going to be 2. So 0, -2, the other one will be 2. That's what my graph looks like. I've got my asymptotes labeled. This is going to be -2, 0. This will be 2, 0. I have no y-intercepts that I have to worry about. I've got my asymptote labeled. That's looking really good. Perfect. And that's where we will stop. Hopefully you found this useful as we're going through it. Maybe you need to brush up on your transformations a bit more, and maybe you need to go through some of those basics of dealing with your CAS as well if you found that difficult. But hopefully you found this manageable, and I'll see you in the next one. Bye bye.